Hello guys, welcome to my channel, and we have a amazing video for you guys today. And it is actually less talked subject, which is software architectures. It is actually not a design pattern. Many people think that it is a design pattern. No, this is actually the higher level. This is the architecture pattern. And as you can see, most of the things that you know already, which is MVC, MVP, MVVM, but many people don't know different kind of architecture like layered architecture, client server architecture, master slave architecture, pipe filter, broker pattern, peer-to-peer, lot of those things. So I want to talk about briefly about software architecture patterns in brief, where I will talk about the design pattern and how it is structured and its component and how it should be used, how it is used, its working principle, and the use cases of them, where it is used in different cases. So many things I will talk about it. So in this lecture I will talk about only the layer architecture, client server architecture, master slave, pipe filter, and broker pattern. And the next part, in the next video, you will see I will talk about peer-to-peer, event bus, MVC, MVP, and MVVM. So let's get into the layered architecture pattern. So the layered architecture, as you can see by the name, it has different kind of layers like component layer, business layer, persistent layer, database layer. It is going from the top to bottom. So presentation layer is the things that you see in your applications, and it has different kind of components that you use in your daily life. Underneath it has business logic, that is making your applications to the proper way that you want, the coders want, or the users want. The persistence layer is the connection between your database layer, where there would be all of your information that is stored in, and your business logic. Presentation layer needs some logic, and for making any logic we need to process our data and get all the data from the database and make proper logic for application to show it on the presentation layer, whatever we like to show. And the object relation mapper is actually making relationship between the logic and the data. So all of those are dependent, and once one layer giving services to another layer. And as you can see, it is very organized. So most of the application will be built using this, because there is different kind of logics there, different kind of components there, which is working as a team to make a particular software work properly. So as you can see, the use cases, it is used for decomposing your program into groups and components. As you can see in the architectures before in the pictures, that it is layered into different kind of groups, and each group has different kind of components to handle something. So it is very organized, and each layer provides services to next level that I already talked about. And a traditional method for designing your software as well, obviously it is traditional way, and it is general desktop application is made using C#. And obviously for e-commerce web applications, you see lots of module like payment method and seeing all of your products based on your categories. And you also see that you have a add to cart options, where you can add different kind of products that you want to buy, and they can calculate different kind of things based on what you chose, and order, payment, customer, different kind of modules it has. And so all of those things need a good management, and it should be in proper component and in a proper group to manage all of those complex things. So it is very easy to implement and very easy to test, because it is group wise organized, and component, all of them are properly organized, and it is easy to modify as well. But it is difficult to scale, because sometimes there would be huge amount of groups and components, so there would be a messed up, and it will be little difficult to scale, and there would be a performance issue, because there is so many components, so obviously there would be performance issues. Always remember that if there is less component, there is a good performance, but if there is huge amount of component, it is always a performance issue. And coupling between layers is hard, because there is so many layers, so the communication between them would be a little bit harder compared to normal architectures, and redeployment issues are also there. So the client server architecture is the topmost used architecture that you see in your daily life, like game applications, chat applications, where real time the server is actually working as a central thing, as a central object or central server that is actually connecting all of the client in a chat applications, all of the clients in a game application that the gamers are using, and all of those gamers that is playing the game on PC, laptop, desktops are the client. and when they log in into the server, game server, they see other players also playing, and they can be connected together and do whatever they like. So the clients actually sends request to the server, and the server actually sends the proper response to the client. And this is very, as you can see, there is only two components, server and the client, so it is really fast, efficient way and very scalable thing. So it is really good for performance gaming, chatting applications and real-time applications. So the clients are the desktop laptops and the smartphones, all those things that we use, and the server are the webs. It can be web servers, it can be mail server that is used to send any mail, and it can be file server like storage, some file, doc file, or any kind of web file that we upload some informations to it. So it has a different own file server. It can be mail server, it can be game server that we use. And to authenticate, we have to be authenticated to use all of those servers, like for email service, Gmail service, we have an account like Gmail and email, all those things. And when we play any games, we also have to log in and register ourselves in order to use that kind of servers are really, so it is really a secured way to use your client and server architectures, and really fast and efficient way to use your server and client. So it is really also secured as well. So the next thing is that the use case of client server architecture. So I already talked about this, the online application, the email services, file sharing, banking, your transactions, your data, sending it to file server and getting it, all of those things. Play multiplayer game as well, chatting between them. And the next thing is the pros and cons. The pros, I already architectures that properly in your brain. We were talking about many things, like it is very centralized, it is very secure, and it is high performance and scalable. Scalable in the sense that you can add multiple client in a server very easily, because there is not many complexity in it. So it is scalable, it has good performance and security. The cons is that one of the pros is can be become a cons, because you can add client easily, so there would be a traffic congestion problem very easily. So if the server is down, then the client cannot get the proper requirement that they want, they cannot play the game, they cannot send the chat, it will be a huge problem. So, and the resources exist on the server only, because the client will not get all the information. It is only resources is only for the server, not for the client. So you cannot get it in all the time, you need to be connected, and the server need to work properly in order to get those things from the server. So the master slave architectures is one of the most toughest architecture for many people, because it has different kinds of server, like master and the slaves. Slaves actually use for reading your the server requests that is coming from the applications, and the master actually do the main work. It integrates all the work that is done by the slaves and mix all of them, integrate all of them, and send the proper response to the applications. So your applications will talk with the master, and the master will distribute his work among those slaves to make it work properly. Because if you send all of your requests into the master architectures or the master server, it would be a huge load for the master, so there would be less efficient, it would not work properly. So it have to make your server multiple layers so that they can work together to make it more efficient. So the main thing is that the difference, the master have the read and write operations, the slaves only can read, it cannot write. So I took an images from Ivan Bojovi. We can understand more about if you go there and search about him, and he tells really well, and I really understand very well how he actually talked about these architectures, because I had to research a lot about this. So he says that MySQL architecture is the master, which have the write operations, and the MySQL server slave 1, slave 2, and slave 3 have the read operations. So web client will read something from the slave 1, 2, and 3, so it will less burden for the MySQL server master to read and write as well. So it can be focused on writes only, and the reads will be done by the slaves. so there would be a nice combinations. And the load balancer that you can see is there, it is a system architecture is also there. So you have to understand what is load balancer is. You can also Google search it if you want to know more about it, but what I'm telling you that the client always send request to the server, so to balance all those requests and response to make it more efficient and balance, the main purpose that you see that the slaves are used for read operation and the master for the write operations. So the main working principle for the master slave architecture that it is consist of masters and slaves, and master distributes work among themselves, so to make it more efficient. And master is for write operations and slaves are for read operations only, but it cannot write. Slaves processes the data that is coming to it and send it to the master for further processing, and the master integrate the data that is coming from the slaves and send it to the client. So there is a nice balance between them. The master slave architecture uses a distributed and large system use this kind of things because there would be huge amount of client and huge amount of things that is working together. So to manage all of those client and this huge amount of requested coming from these applications, we need a distributed systems that uses master slave architectures, and also used for about database failure, because one database fail another database can help you to get your information. So it is really useful for the client as well. And peripheral connected to the bus in a computer systems, so all of the things that is connected together in a bus. So you need to understand this really well. So the pros and cons are here. The pros are read access on multiple servers, so you can read access on multiple servers, so it is really efficient to use, and avoid single point of failure. So if one server goes down, it will not fail you, it will get something response to you. So it is really good for both the server and both the client as well. Data analyzing on slave, as you know already, the data analyzing is done on slave and it is sent to the master, and it also helps out overloading the master. The cons is that there will be lots of processing and there will be huge amount of resources, and the data partition can be must be done very carefully. Application must not understand database topology. It means that you need to make the application in a way that it understands the master slave architecture, that it has different kinds of server. Your application must be coded in that way. So the processing would be huge amount of, because there is so many servers and the managing is so hard, and failures increases complexity. If you messed up your all of your servers, it would be hugely complex to make it work properly. And so it is very complex, but is as well very useful for the client and the server for loading issues, and also for the client to get proper information if one server is down. So there will be always pros and cons in different architecture, but you need to use it in a proper way, in an engineered way that you want to use it. So I made this for you guys so that you can understand different kind of architecture and how the use case of it. The pipe filter architectures is actually has two components. It has the pipes and the filters. The filters is actually the things that actually filters all of your data, and the pipes is the things that send and receives this data to the other component. So as you can see, there'd be two main thing, which the data source, and there will be huge amount of source there. It can be from database, file source, system. The data would be here in the data source, and the data source will get all the data from it and send to the filter using the pipe. So pipe is nothing but a tool that can stream all of your data to the filter. So pipe doesn't know anything about it. It just send the information to the filter. Filter does all the things that they need, like it filter all of your data based on your logic, what they need to do, and it will process it and send it to next filter. And the second filter that you are as you can see here, will be using the data processed by the first layer as an input and send it to the third layer, and the third layer will also use this kind of data that is filtered by filter 2 as an input. So it will go on continuously, and the pipe will send the filtered data as well all the time, and in the final stage it will send it to the data sync layer. So this is the main workflow of pipe filter architectures. So it is very reusable and loose and flexible coupling of components, and conducive to parallel processing. So if you want to make your application parallel processing proper way, you need to use pipe filter architectures. and it is really flexible. And the black box, users don't need to know the business logic. So some users actually don't need to know the business logic, they are completely out of it. And the cons is that reduced performance due to excessive overhead. If you throw huge amount of data to the pipe, it might overload, and you may lose information as well. So there would be a huge amount of problem here. And you cannot use it for interactive applications, that like game applications, chat applications that is interactive and that is connected to the users all the time. You cannot use it for real-time applications properly. And it is not also appropriate for long-term or long-running computations. It is used very less places like Unix program, macOS and Linux based systems, and compilers. If you know about compilers, and if you take any courses of compiler, you understand how the compiler design work. Like it has different kind of stages like lexical, semantic, parsing, code generation, and after all of those things, if you understand all of those things, you can make a proper IDE or compiler that compile your code into the assembly code or your machine code that runs properly on your software. So if you are into compiler design, making proper compiler, that you should use this bipolar architecture, and other than that you shouldn't use that as well. So broker architectures is the pattern is used to architect a distributed system. It is not a one system, it is a huge amount of distributed systems that work together. It uses a middleman called broker to coordinate between the component like client and server. So there are total 3 components in broker architecture. One is the broker itself, and then the client and the server. It takes request from the client. So client will always request something or services from the server, but it cannot reach it to the server directly, and it would send the proper request to the broker, and the broker is able to send it to the proper server to get the desired services offered by the server, and get the server response and send back that thing or the response to the client who wants the service. So this is actually a 3-way thing. So let's understand this using these architectures. So there are 3 things: client, broker and servers. So in our application we see that there can be multiple servers. So which server is actually giving us the proper service that we want, and we don't have to make any headache, or we don't have to think anything that which server give the proper response. We just request to the broker, and broker will find the proper server for us. Like when we are buying any thing like buildings or anything that our houses, we go to broker, and the broker will understand what kind of building that we want. We give the broker the proper request, and the broker will find the proper buildings, proper room, proper weather and proper square feet, how its price, everything will be managed by broker. We just tell broker, send request to the broker, and broker will find the proper things for us. This is actually the main thing that broker architecture is being used. So let's talk about more specific thing in terminology. So there are many different kind of category here. First we have the client and the server are on the 2 sides, and we have client proxy and server proxy as well, and finally we have the broker that will match the proper client with the proper server. So as you can see in the middle, we have the service interface that performs some functions, and the client and the broker would be connected using the client proxy. Client proxy have the power to connect the client and the broker, because client doesn't know anything about server, it doesn't have to know anything about server. It will connect to the broker using the client proxy that will say like for sending request, marshal request and earn marshal response. It means that getting that proper response from the broker, not from the server, from the broker. So the main thing is that client proxy does send request and marshal the request. The server proxy on the other hand, it does the marshal response. It sends response, marshal response and earn marshal request that is given from the client to the broker. So earn marshal request is the request that is given by the client to the broker, and the broker send it to the earn marshal request. Now what the server proxy give it to the broker is actually the response, the marshal response or the send response. So these are the two things that you need to understand. The server actually send the response to the broker, the server proxy, and then broker will send that thing response to the client proxy, that is actually the unmarshaled response. That is response that is coming from the server, from the broker and to the client proxy, and then this thing will go to the client. So in between, what the broker has to do, it has to locate proper server that serves the client properly. It also need to find proper client, like use it serves the locate the client using the client proxy who is sending the request. It also locate the proper server in the server proxy who sends the response from the server. And it also register the server. Without registering the server, you cannot access anything from the server. It also unregistered the server. It also have the ability to do that. And it also forwarded the requested that is coming from the client proxy and forward that to the server using the unmarshaled request. And it also forward the responses that is coming from the server proxy and send back to the client proxy, which is unmarshaled response. It will decode the response and then send it to the client proxy. The same thing. So this is the main architectures of it. It has the ability to locate client, server, and proxy, forward your request, forward your response, all of those things. So if you understand this kind of structure, you understand the broker pattern. Really simple. So you have to know more about broker architecture. So only the understanding the architectures is not enough. You have to know the responsibilities of it and the collaborators of broker. The responsibility of the broker architecture is that it registers and unregisters with the server. It provides an API for the client and the server as well that they can use. So it is working as a middleman, which provides different kind of API for two opposite sides, which is client and the server. And it has the ability to transfer messages through them, error recovery, if any problem it can error recover, and interoperate with other broker systems. So there can be multiple broker, so it also have the ability to incorporate with other broker system via bridges. So bridge actually connected the broker with another broker, so it is also a network between them. It also have the responsibility to locate proper server. So this is the main purpose of it, to locate proper server for the client. The collaborators is the client server server proxy, server side proxy. Client side proxy is all you already know, connect the client and the broker. The server side proxy connect the server and the broker. And the bridges actually locate broker and remote broker. So the broker architecture, the use cases of broker architecture is huge amount. Common object relation broker architectures, IBM SOM and DSOM, which is system object model or based on shared library. So you are making something a library which is shared among different kind of systems, and different kind of system can use this kind of things, which means that it is very reusable. If you make anything, you can use it on multiple systems, that kind of code, or in applications, any kind of things that you made as a library, you can use it on multiple systems. OLE, COM, DCOM, ActiveX in Microsoft services, different kind of things use its kind of things. So if you want to know about OLE, COM, DCOM more, you can search Google search on it and why they use that kind of thing. And the next is that World Wide Web. You already know about it, and it is so the use cases of it is huge amount, especially in the distributed system and World Wide Web. It is heavily used. Broker architecture has the location transparency. Client don't have to know which server the data is coming from, response is coming from. So they don't have to know anything about the server. The broker will manage all of those things for them. And changeability and extensibility of the components. You can change any component, you can extend it to bigger level, and you can add or remove more components to it. And it is very portable for the broker systems, because it is very portable means there can be different kind of broker that would be used as well. Not only single broker, there can be multiple broker that is working to find proper server for you. And it is also very reusable because it is distributed system. Once you make anything using broker architecture, you can use it on multiple systems. And restricted, the cons here are the restricted efficiency. Like restricted efficiency is meant that there would be three layers working: client, server, and the broker. It is not actually the client and the server. There is three-way connection, not a two-way connection like client server architecture. The broker architecture is not that efficient because of that broker in the middle between the server and the client. And it is lower fault tolerance, and testing and debugging would be really tough because there is multiple structures that is making through the API services, like sending a request from different kind of server, and your client doesn't know anything about which server it is coming from. Only the broker knows it, so it is completely difficult to test and debugging, and lower fault tolerance is also there. So the problem is with the efficiency, testing, debugging, all of this, making it complex. But the usability, and you can use it on many component, and it is very portable. So this is also the pros of it. This is actually the part 1 of my video. So in the second part we will see other architectures that make you a better software engineer, that you understand many architectures on the top of layer of your programming skill. So this is actually not talked in many videos, so I wanted to make a video that talk about this kind of architectures. It is really important to understand software architectures and design patterns, and also your coding skills as well. So let's see you in the next video. So this is all for you guys. I hope you like these videos, and thumbs up if you like it, and comment me if you want to give me some advice on making proper videos, and so that I can improve myself. All for it guys. I will see you in the next video, in the part 2, where I'll talk about more 5 architectures for you guys. So till then, thanks for watching guys, and be safe, and bye bye.